Good afternoon, everyone. Welcome to my talk. My name is Chao. I lead the data science team at Lucidworks. Today, my topic is automatically build Solr synonym list using machine learning. As we all know, synonym list plays an important part for search. However, it usually takes a very long time to detect and maintain the synonym list for search or ontology group in a company. Thus, we explore different machine learning methods to help automatically generate the synonym list. Today, I would like to walk through our algorithm step by step and compare with existing methods. Also talk about spell checking and phrase extraction, which are the two components of the synonym solution. Additionally, I will provide example output generated from Lucidworks software within the context of our e-commerce search use case. This use case, we download data from Kaggle. This is using the search log and catalog from bestbuy.com. So you can see a lot of examples around searching for electronic products. So let's get started. So if you look at the Solr synonym list used in different companies, in general, there are 4 types of things in the synonym list. Of course, most importantly is the synonym. It's basically swappable words, you can do query expansion without impacting the search relevancy. For example, if people search for bag, you can expand to case, and then also different wording of the same thing from your customer. For example, Mac, Apple Mac, MacBook, or a MacBook without blank in between. Another second type is the acronym. For example, PlayStation can have PS in short. And the third type is misspelling. If there's a frequent misspellings that Solr spell checker cannot handle, I see some people use one-directional synonym and put different variation of the misspelling and put the correction on the other side. And the fourth type is misplaced blank spaces. It's pretty typical, like your customer can misspell certain brand, for example, KitchenAid, or here is Whirlpool with blank in between. Then we should map to Whirlpool. Or you have book and with or without blank space in between. Both exist in your catalog. Then you can put them as bidirectional, as one-directional. So in summary, our goal here is to automatically find all these types, including interchangeable words for query expansion, find misspellings and its corresponding corrections. We also need to decide the format. It should be one-directional or bidirectional. And then we cannot just limit it to just finding single tokens. So we should be able to find phrases with multiple tokens too. So let's see how we can achieve that. Before I go to our algorithm, there are already some experiments around how to automatically generating synonym. And I will talk about 2 of the most popular methods here. The first one is knowledge-based methods such as Wikipedia and then WordNet. WordNet has a synonym list that you can use. But the main problem with using WordNet is it does not capture or have a good coverage of your customer's own ontology or context. For example, I run the WordWhack on this e-commerce data and generate some synonym like this. It's mankind, it's humanity, luck is chance, interference is noise. Yes, they are synonyms, but they are general context synonym. And it's not useful in the context of electronic search. And the second problem is it's missing a lot of context-specific synonym that should be there in your synonym list. For example, the second line you cannot find in the WordNet. For example, different wording like a Galaxy and Samsung Galaxy, the same thing, and variation of saying Wacom is VAC. Because you cannot find those in the WordNet, because WordNet is a very standard word list. You cannot see those outbursts there. And interestingly, sometimes in the customer context, it can be synonym, but actually it's an antonym in WordNet. For example, if people search for both noise and both quiet, they are searching for the both noise canceling headphone. But you can clearly see noise and quiet is antonym in WordNet, but it can be synonym in your own context. And last but not least, this list do not update frequently, but we require our synonym list to be updated in a very timely manner because you have new product all the time. And the second most popular is, of course, WordWhack, or some people call it embedding method or neural search. And WordWhack is a shallow one-layer neural network trying to predict target words from surrounding words or vice versa. Then we can take the dense vector, or you can call it embedding, out. Basically, a transfer from your own data space to another dense vector space, and then find the nearest neighbors through cosine distance between the vectors. But because the vector live in a vast high-dimensional space, and any two vectors can be similar in any sense, because there's no constraint applied in the WordWhack algorithm. For example, you can see red and blue are similar because they're both colors, and broom and floor share the similar functional relationship. So they are related words. They are not interchangeable words. But in your search context, you need the synonym to be interchangeable so that you do not impact the relevancy. For example, if I search for king bed sheet, I do not mean I want queen bed sheet, right? If I want red painting, I do not want blue painting. Because of the way the WordWhack model is constructed, trying to predict the target word from the context word, you can see a lot of results is like providing surrounding words rather than synonyms. It found like rechargeable battery, unlocked phone, or power supply. They are nearby words. They are not synonyms. So this is the second problem. Also, since the WordWhack using SGD is doing a local optimization, it's not doing a global optimization, and there's kind of sensitive to hyperparameter, for example, the window size and also the number of dimensions. So in summary, the methods currently existing for the WordWhack is kind of lacking the constraints on top of it. So it's kind of too free to find anything. And then the problem with WordNet is like it's losing the context of the semantic context of your customer-owned data. So we consider of those two major problems. So we propose a 5-step synonym detection algorithm here. I did different kind of experiment, and I found that a good way to utilize the information is to use users' search log data. So nowadays, different websites can easily track and store user events such as queries, result clicks, and purchases. And you can use this collective behavior to create clickstream model or LTR. And actually, this can be a very good input data to help find synonyms. So the first step we take is like we first find similar queries. Then we further extract the token of phrases from the similar queries. Here we have an assumption. So this is the signal or user click you can extract. For one query, you can get the document ID, what kind of document people click on. And also, if you do some aggregation, you can find for this query, they click document 1 500 times. With this input data, what you can do is like, we have an assumption here. I assume like query 1 leads to a set of document 1, 2, 3, 4. And then query 2 leads to another set of document 1, 2, 3. If those two sets of documents have certain overlapping, then very likely those two queries are similar queries because it leads to the same set of clicked results. Then what I use the JGAR index. It's pretty standard index to measure the intersection and then divide by the union of the two sets. Also, since click data can be noisy, there can be some maybe just click one document once. Then we adjust it by the number of clicks to do some denoising here. And after doing this computation, what you can see, we can find very similar queries. So here's the example result we got from the e-commerce data. We can find PS3 cooler, PS3 intercooler, and we have a similarity score as a confidence level. And other examples, iPod shuffle cable and the shuffle charger, similar things. And also, this JGAR index works pretty well, give a pretty good descending order. The higher of similarity, the more similar it is. And if you see the last one with a 0.45 is a low number one, then those queries may not be exactly similar, but it's not bad quality either. It's kind of PowerShell, and SD750 is one type of it. But you can see with the descending order, you can set up a threshold. So actually, in our product, we allow you to configure it. It's like if you want everything below 0.5 to be dropped, you can easily set up that threshold to have higher quality synonyms. And then before we do further extraction, we do some pre-processing. For example, I don't want to put all kind of stemming in my synonym list because Solr can easily deal with stemming. So I do the stemming on the queries and do stop words removal. And then two more important steps is to find misspelling and phrases. So you can use this job to find misspellings, but the drawback of that is like if you treat misspelling as synonyms and everything is bidirectional, then when you do the query expansion, suppose there's a correct spelling of matrix, then you have to expand it to all kind of misspellings. It's kind of waste of without power and time. So misspelling better treated separately so that you can identify which is misspelling, and then you put it as one directional. So I will talk about our misspelling job in our software later, separately, later in the talk. And another thing we do is like we identify phrases. That's a separate job in our software, can identify phrases. Suppose you already identify a list of phrases, then in the query, if any of the 2 or 3 tokens appear in your phrase list, I put an underscore in between and change it into into one token. This way, you can find this kind of multi-token synonym mapped to the other multi-token or multi-token to single token. Then it's pretty flexible, not just limited to one token. And then the third step is do the synonyms extraction. So the way I did it is like I extract the token phrases from queries by finding token phrases which before or after the same word. Because I already find a similar query, then there can be laptop charger and laptop power. And since charger and power are all following the same word, laptop, and I assume it's synonym, it's basically finding more abstract information so that the synonym you find can be more generalizable. It don't need to be like following certain words all the time. And another example, PlayStation console and PS console, and then since they're all like before the word console, and then PlayStation can be similar to PS. And similarly, we add a synonym similarity score by counting the occurrence in similar query adjusted by the counts of each individual synonym, so that you can trim the low similarity ones. If you just look at the algorithm, this method looks like a very naive method without fancy modeling involved, but it turns out to work pretty well because I think it's because it's a very straightforward way to replicate how people construct queries. So compared to WordWhack, it did not project to a different vector space and then project it back to find similarity. It worked directly in the query space and then finds the first order information. And of course, if you're using click data as the input, there will be noise for sure. So we do a series of denoising steps. For example, 2 of the important steps is like I drop the synonym pair that exists in the same query. Because what I found is that people usually don't use the synonym in the same query because they do not repeat the same information. And then this way you can drop a lot of the noisy pairs. For example, you get from the WordWhack, like rechargeable battery. Because rechargeable battery is surrounding words, they usually show up in the same query. And if you drop those pairs, you can increase the accuracy. And another thing I did is like there's an assumption synonym should be transitional, which means if I found LTED TV is similar to TV, LCD TV is similar to TV, then it should be LED TV is similar to LCD TV, because if they're all similar without direction, they should be transitional. But if you cannot find any connection between those two nodes, then it's possible to give you a hint you should drop those two pairs. So what I did, I apply a graph model, basically find the biggest community, have enough edges in this graph. And a byproduct of running this model is like you can get a synonym group. So for example, if all three are connected, then Mac, Apple Mac, and MacBook are all similar, then you can group together as a community. If you extract community out, it's basically a one line of synonym group in your synonym list. So if you do not have this group, if you only have Mac is Apple Mac and Apple Mac is MacBook, then when Mac show up, you can only expand to Apple Mac. You cannot connect it to MacBook anymore. But if you do it a group and then it can expand, any of them show up, then you can expand to the rest. And then to do like a triple or double times the expansion. And the last step I did here is sometimes the cutting can be too extreme. I mean, like can be too abstract. Then what we need to do is like adjust the position to see whether you use the context or not. By context, I mean because we are trying to find the most frequent showing up before and afterward. The context can help you understand why this is a synonym. I basically put the output is like what's the most frequent before afterward surround this synonym pair. And then there's a tree-based model built to help you automatically predict when to use the context and when to use the synonym pair. Because sometimes if you do not have the context surrounding words combined with it and the meaning is not clear. For example, if it's just a game and PlayStation, game can be all kind of games, but PlayStation is kind of machine, right? But the reason it's get picked because the context show up as the game console and PlayStation console. Then if you think game and PlayStation is not good enough, the model will tell you you better use the context with the console following so that the meaning can be more clear. So this is the 5-step, and then this is an example output from our job. There's several fields help you understand. It's like the synonym pair, the context, the synonym group generated from the graph. For example, in the group, we can find all kinds of saying of the same thing: the earbud, earphone, ear, blank phone, headphone, ear blank bug, and ear headphone. So it's kind of all kinds of things people think expression of the same thing. The context number is like the number of times the synonym pair appear in different contexts. The higher is the number, the more likely you can choose the synonym pair. And of course, there's the similarity. The suggested pair directly help you decide when to use context, when to use synonym. And also, there's a 4 type of category we put here. It's a normal synonym or context, and then acronym is basically find a modern warfare MW is kind of an acronym. Also, there's misspellings. So then you may ask, you already told me you will treat misspelling separately. Why there's still misspelling here? So the reason is like we have a separate misspelling job. And usually we put a very conservative parameter setting so that you can find high accuracy misspellings. But here you are already finding this in the similar query. So given the situation that similar query is very likely the similar thing, here I usually relax the parameter setting and can help you find additional misspellings. And sometimes it's not necessarily misspelling, it's just a different expression like the English or the American English or the French. It's like it's not necessarily misspelling sometimes. Also, it's like we provide the counting, like number of times the synonym show up in your search log. When you review it, you don't want to look at pretty rare stuff, and then you can just cut those and only focus on the very frequent occurring stuff. Okay, so let's see the comparison. So I tried different, so here the purpose is I want to compare to WordWhack. I tried different ways of running WordWhack, And then I found the best way of running WordWhack in this use case is to run WordWhack on catalog data. Because if you run WordWhack directly on queries, queries is usually short. It's like only 2 or 3 terms. And then you do not have enough vocabulary in your model to learn the embeddings. So, but the catalog have enough words in the descriptions, and you can have a wider windows to be used and build better model. And after I find the WordWhack, I trim the rare terms that not show up in queries to increase some accuracy. And I also apply the same misspelling and phrase extraction step on WordWhack, so that it's kind of a fair comparison. And then you can see this is the result. It's like it finds, again, related words, night and day, 2 and 3, and surrounding words, universal charger. I do find some good one, like a mobile phone and cell phone, or some totally unrelated one, like not unrelated, related a little bit. And then another problem is the similarity you get is not having a good descending order. So the higher number one doesn't mean it's good one. So that's another problem. I'm not saying this is useless. This is still useful. I think the use case for this is like when you have 0 result. It's like if you do not have night light in your catalog, then you can expand it to daylight, right? So when you have 0 result, you have nothing in your catalog, you still want to present something, you can use it. Or you do not have Super Mario 2, but you have Super Mario 3, which is even better, then you can serve it, right? And then when I do the evaluation, what I did is like I do some ensemble using different methods, different runs, and generate all the possible synonym pairs, and then also manually look into the queries. And I build a ground truth data to manually evaluate. And for this kind of pair, I didn't label as synonym because they are not interchangeable. Again, it's still useful, but it's just in my study, I want some interchangeable words. So those pairs are labeled as 0. And then after do the labeling and comparison, you can see our Lucidworks synonym job have an F1 score at 82%. And then the WordWhack method I described in the last slides have 29%. And what I did is like, remember I have a step 4 in the algorithm have the denoising step. Because what denoising do, remember, is like drop the things appear in the same query, then can solve certain degree of the surrounding words problem. And after I do that, the precision do increase by 14% with sacrifice recall just a little bit, but still like 32%. So there's a 50% difference between WordWhack and our solution. So it's kind of a little bit surprising because in the industrial academia, not many people focus on the interchangeability of the WordWhack findings. Everybody is only focused on whether it's related or not. But this is like search focus application. Our bar is higher here. Okay, so the next session I'd like to walk through a series of query analytics jobs in Fusion. If you already know our company, Lucidworks, have a flagship software called Fusion, which combines the power of both Apache Solr and Apache Spark. And in the last few years, we built a series of machine learning algorithms around it. And a lot of algorithm is taking the input data, which is this like a user click data. And we have a new add-on app called App Studio, can automatically track users' behavior and automatically save this data in the Solr collection for you. So this is the type of data we got. We have the document ID, we have the query term, we have the timestamp, and what type it is. It can be purchase, add to cart. Here the type is click. And if you want to do recommendation, of course, you can track the user ID. One of the jobs as a prerequisite of the synonym, because we need to have a lookup table for the phrases, we have a separate phrase extraction job. Phrase actually plays a very important role in query intent. For example, income tax and home security system have certain meaning when those words combine together. If you just use vanilla Solr and search for income and tax, it can give you documents have the word income. if we mention income several times. Or it can just give you the document mention tax several times. But income tags together have certain meaning. So basically, you can run this Spark job to find commonly co-occurring terms. And then as for usage, there's two main usage here. Suppose a query come in, and then you check against your phrase list. If any of the two terms falls in the phrase list, then you can do this kind of a phrase boosting to make the relevancy better. And a second way is like, as I already show you, is like put underscore and make it a single token so that you can feed into downstream jobs such as you can do clustering classification or the synonym detection job to increase the accuracy of the model. Here is an example output from our software. It's like we find the phrases like a hard drive, LCD TV, Blu-ray, and then we give the phrase counting, is how many times those terms show up together in your signal collection, and we use the likelihood function to compute the phrases, and then if your rank order is the lower order is less likely. And another thing is kind of unique is like we automatically tag a review tag. Review means it's like if the review equals true, it's like we're not very confident this is a phrase. And then when you review it, you better put actual attention on it. For example, external hard and the Canon digital obviously cut at the wrong places, but luckily our likelihood is low, and then we have a review label on it so that when you review it, you can look at those things first. Next, I'd like to talk about the spell correction job. So we have advanced spell correction job in Fusion. Then you may ask, why bother to build another spell checker? Solr already have a spell checker. So here's the difference. So the Solr spell checker is index-based. It's checking against your catalog. But as we all know, catalog have all kinds of misspelling in it often. So if you just use your catalog as the ground truth, you can correct to the wrong, another misspelling rather than the correction. And another thing it did is do the query time checking all the time. So you usually, unless you do extra tricks, you don't know what is corrected to, because it's like doing things on the fly. So in consideration of those two jobs, so I hope you the Fusion spell checker. Again, it's like a click data based. The logic behind it, we assume the words or phrases have a lower number of clicks, misspellings, but have higher number of clicks, corrections. And then we provide the option to check against your catalog in the later phase of the job too. So it's not like we're not using catalog. It's just it's not the direct input data. And since it runs offline, it gives people the opportunity to review to make sure the changes are all correct, because you can just look at what each thing's correct to. Another thing is like if your query clicks are captured after Solr spell checker already turned on, and then you are basically capturing the misspellings from the click data, mainly identifying the erroneous corrections or no corrections from Solr. And another big benefit is like this job have high accuracy. We experiment on different data set. On average, the accuracy rate is 96%. And the way we achieve that is like we incorporate all the basic Solr parameter setting there. For example, the maximum edit distance, the prefix number, and collision check. We have all these. And in addition to that, there's a few differences. So it's possible you'll find multiple possible corrections. Then which correction to choose? We have a formula behind the scene, and using multiple criteria in addition to just the edit distance. There are other features we use. And also, rather than using a fixed max edit distance filter, we use a edit distance threshold relative to the query length. Basically provide more wiggle room for longer queries. So if I have a query have 10 characters in it, and you can allow 3 or 2 edit distance. But if your query is only 4 characters in it, you better don't allow 2. It's 1 is even sometimes it's too much. And again, since the job is running offline, you don't need to care about the expensive runtime considerations. For example, there's a parameter in Solr spell checker. It's like it's called maximum inspections. You have to limit the maximum number of possible matches to review from Solr. But since this runs offline, you do not need to consider that. And then to minimize the query time processing load, regardless of the problem complexity. Here is the example result. It's part of the example result. So here we provide the misspelling and the best match correction, tons of metadata, the token size, the misspelling length, the ratio between the correction number over the misspelling number, edit distance, whether the syntax match, whether the last character match. And by default, we order by the misspelling length descending and edit distance ascending to put the most confident corrections on the top. And since we borrowed the idea of collation in the Solr, we provide additional fields to see the relationship between the phrase level correction and token level correction. Here we provide both phrase level and token level because sometimes it needs some context, additional words to help you decide which things to correct to. So, but sometimes the phrase level correction can be solved by token level correction. So we give you the information how many times the same token appear in the phrase level correction. And then also we have a review tag here. If we are not confident about the correction, we'll put a review tag. For example, here is a coder is correct to cover, and we are not confident of this correction, so we put a review tag. And two more interesting category in the correction types is called combine or break words or combine break words bidirectional. So this is exactly solving the problem I mentioned in the synonym list. Sometimes put misplaced blank space in between. For example, Microsoft Word should be Microsoft blank Word. And then since we allow people doing checking against your catalog, if the head blank rest and head rest without blank in between both show up in your catalog, and then we'll tell you that, and we say instead of one directional, you can use bidirectional because you can find both in your catalog. As for the usage of this spell checker, again, you can put into Synonym List, and so we recommend run this job and use as an amendment of Solr spell checker. Solr's main function is like checking the creative misspellings happening on the fly, and then this job can catch the frequent occurring misspellings and make sure the corrections are correct. Also, another thing we can do, since this job have higher accuracy, before you configure a Solr spell checker, you can run this job first and then generate a ground truth data. And then you can tune your Solr against this and against this ground truth data and to see until the agreement between each engine is higher. Also, you can put in a UI, set up typo header, auto suggest when people mistype something, you map to the other thing. And of course, as we've seen, like in the synonym job, you can do the document cleansing. You already find the misspellings, and then you can use this list to clean your product catalog so that your Solr misspell check can increase accuracy. Okay, after all these efforts, we find the phrases, we find misspellings, and then we find synonyms, and then we find the groups. After we combine all this information together, you will see this beautiful list automatically generated by machine learning. We find the group of expression of the MacBook, different headphone information, and then map all the different misspelling of accessory to the one directional, and then you can choose bidirectional break words or one directional break words. So this is the example result generated by our job. A quick 1 minute upsell is, so we also have this head tail analysis job. If you look at watch my background before, you may already know. It's like we find it's a phenomenon. It's like a lot of the tail queries actually a variation of certain hack queries. And then utilizing this logic, we can provide automatic rewriting of the tail queries. And then we can give a reason code why this is a tail query, and then boosting or dropping different part to increase the relevancy. And then based on the tail reason, we can give you an investigative chart so that you can tune your engine more proactively. For example, for this e-commerce data set from Best Buy, number is the most problem leads to tail because it do not treat dimension search very well. An example is like people search for 27-inch LCD TV, and then in their catalog, they only have INCH as inch, but a lot of people search for 27 quote as the inch. So then they cannot find it. So if you run this job and do some investigation, you can find the problem more proactively. And this is an example of the rewriting. Suppose you have a tail query called write case for MacBook.Pro, and then you can, if you just plainly search for it, you can get the result on the left because it matches the words case and for. And then it cannot find anything with MacBook.Pro. But if you do the rewriting, you can see you can do the phrase treatment and then drop the dot and then also find out there's a color in it and then just a search within the color field. And then you can get the results on the red automatically. Stitching everything together, last part, I will take let's take a look at the workflow in Fusion to generalize and utilize those results. This is one example of our job configuration. You can just directly put where's your signal, where's the input data, where you want to output the list, and then there's some tuning parameters you can tune. But the good news is like for each of the job, we already experiment on different data set. Usually the default works, unless your data is pretty skilled or pretty special. And since there are some dependencies, for example, if you want to generate synonym, you have to run misspelling and phrase as a prerequisite. But in the next release in Fusion 4.2, you don't need to do that. We automatically schedule these jobs for you and then set up the proceeding who runs first. And all you need to do is just enable it. If you like it misspelling, enable it. If you don't like it, turn it off. And then you can pick and choose in this menu and you'll get everything. Another cool thing is like we put a UI on top of the output so that you can do a review in our UI. For example, this is one of the synonym toy example we use. For each search term, we find the similar synonyms, and you can spread it out and then to reject or approve each of the synonym. If you want to add your own stuff, you can add new. You can click on alternative to see the context, and then you can sort by any fields you want. And then we will set up the job periodically run and check out the things you already reviewed, so you don't need to see the things you reviewed already. And at runtime, how to use these things. In Fusion 4, our engineer currently is building the query pipelines, and we will have a pipeline available and to basically do the query rewriting for you. When misspelling come in, we correct it first, and then if we parse and boost on the phrases, we do query expansions utilizing the synonym results, and then automatically rewrite the tail queries. So for the future, as you can see, another popular way, I'm not sure popular, but there are some people looking into the session logs. Basically, one person search in the search tree, and then you can see if it cannot find certain things and then rewrite to certain things. What I found from the session log difficulty here is a large part is actually misspelling because the vocabulary of one person can be limited. So I think the synonyms is like collective behavior of multiple people. You can find more things, but it doesn't mean like a session is not useful. But the session is sometimes it's like hard to define one session. Also, the search can be navigational. It's like I find a bad sheet and white bad sheet, and then certain brown or bad sheet. It's just navigational. It's not necessarily trying to find synonym. Another thing is like in our step, you can in step 3 when we extract synonym from queries. One of the problems is that we have to use the same before and afterwards, which limited the usage because there can be no same words show up in the query pairs. And in order to deal with that, one thing worth to try next is like currently there's technology called neural machine translation. It's basically a sequence-to-sequence model using RNN or LSTM. And then if you put an attention layer on top of it, so attention weights basically give you a soft association between the words. And then you can easily visualize it. For example, I translate English to French, and then this French word is corresponding to this English word. And we can use this technology. What it means, like if I have query ABC and then another similar query CDE, and then even they do not have the same word appear, and we can use this mapping and to see exactly which words and tokens are mapping to correlated to each other. Then we can find more stuff for the synonym. And of course, we want to evaluate results on more types of data. Currently, the comprehensive evaluation is mainly on the e-commerce use case, but we want to explore more types. A quick thank you note is like currently the engineer team is building the query pipeline, Tim Potter, Appeal, and Kiran. The data science Sankit in my team is helping with some synonym job optimization to make it run faster. The initial phrase extraction job is written by Lashia. One last advertisement. Sankit, who will give a talk tomorrow afternoon, will talk about our work on QA system using deep learning, also sentiment analysis using deep learning. So it's a pretty interesting talk, and we'll demo some cool results. All right, thanks for listening. Any questions? How many time we have questions? How many? No questions? What's your question? Yeah, I can hear. Yeah.
In Solr, if your edit distance is greater than 2, on the processing time to get the result is much longer. So I'm wondering in Fusion if it can handle replacements or respelling because of the added features. Can it handle misspellings that have an edit distance greater than 2?
Yeah, of course, because this is an offline job and it's running using Spark. So Spark is super fast in parallel computing. It's not like using Solr to do the offline job. We're using Spark. So Solr is slow because it's doing everything on the fly. And then you should limit all these kind of constraints. But again, this is an offline job. You let it run for several days. Nobody care, right? But it won't run several days. It's pretty fast. Maybe one more question. Yeah?
So I'm curious, a lot of other talks about this kind of thing, they talk about you need a lot of data. But I know she didn't mention that. I'm wondering what level of click-through data do you need to collect for this to become applicable? Like 1,000, 100,000, millions?
But on our e-commerce data, you can easily collect 1 million data over a week. That's pretty simple.
You need 1 million customers a week to...
It's not necessary. It's like, I think a few thousand is good enough to start. The more you get, the longer the list you can get. Yeah, it do not require, because it's not using like WordWhack, have a big vocabulary. It's just a very simple statistics. Yeah, that's one of the benefits, actually. Yeah. All right, thanks.